Hello and welcome to lesson 7.2. First thing I want to do is apologize for lesson 7.1. I thought I had the correct notebook when I went to do the notes, but obviously I didn't, as you probably noticed. So, anyway, I will send you all a copy of the notes that I actually used to do the video. I'll also have them available on Thursday. Also, if you don't have a printer or don't worry about it. Hopefully, you understand how to balance a chemical equation and can work out the homework and take the mastery check without having that information. But again, I super apologize for that. Just, my brain was still on spring break, obviously. Anyway, so moving on to lesson 7.2, I believe this is correct. I believe I have the correct information now. But we are going to be talking a little bit more about chemical equations and all the information that you can get from one simple little chemical equation. Remember, I mentioned before that this is like a recipe. So, a chemical equation is basically a recipe. We have one here that's very simple. It's drawn out in pictures. We have one nitrogen molecule. We have three hydrogen molecules, and you can combine those two things to get two ammonia molecules, with each with one nitrogen and three hydrogens. One nitrogen, three hydrogens. But there's two of those molecules can be made from one molecule of nitrogen, three molecules of hydrogen. These numbers out in front here, these coefficients, also correspond to the number of moles that we can make of each of these. I guess technically they also correspond to the number of dozen, if that's an easier word for you to understand. But basically, this equation tells me that if I have 1 mole of nitrogen and 3 moles of hydrogen, I can make 2 moles of ammonia. So from this equation, we can come up with a ratio of each reactant and product to another that will help us figure out, as you'll see in a little bit, the amounts we need to actually work the recipe. Remember, I said yesterday, you're not going to just bake a cake, we're going to just throw stuff in random, right? There's actual amounts that you need. Well, this equation gives us the actual amounts that we need in moles. We need 1 mole of nitrogen, 3 moles of hydrogen to make 2 moles of ammonia, right? So you see here we can get these mole ratios. What is the mole ratio of ammonia to nitrogen? It is just basically a fraction or a ratio of ammonia over nitrogen. So ever how you've learned to write ratios, it's either 2 to 1 or 2 to 1. 2 ammonias from 1 nitrogen. Right. We can do the same thing with the ammonia and the hydrogen. Right? This ratio is a 2 to 3 ratio. So for every 2 moles of ammonia, we need 3 moles of hydrogen. So the ratio can be written again like a fraction or as a ratio with a colon in between, 2 to 3. Right? We can also do the ratio of nitrogen to hydrogen, right? Say my boss says, oh, I need you to make 2 moles of ammonia. Well, I need to go and look what I need, right, for my ingredients. And what if I only have 2 moles of hydrogen, right? Well, then I can figure out how much nitrogen I need. They all work together. But the ratio here is 1 to 3, which can also be written 1 to 3. Right? So those coefficient numbers become very important, which is why it's crucial to have these equations balanced. So you have the right numbers in your recipe. So now looking at this, here is all the information that we can get from just that one equation. Just this one simple equation right here tells us all this stuff. it tells us that 1 molecule of nitrogen gas reacts with 3 molecules of hydrogen gas to form, number out in front here, 2 molecules of ammonia. We can state that in a different way, right? 2 moles of ammonia can be produced from 1 mole of nitrogen and 3 moles of hydrogen. Again, those numbers out in front. If there's an excess of hydrogen, so we have as much hydrogen as we could possibly want, and 2 moles of nitrogen, so we have double the amount of nitrogen, we got plenty of hydrogen, how much ammonia can we make? Well, we will double the amount of ammonia we can make, right? So excess hydrogen, 2 moles of nitrogen, we can make 4 moles of ammonia. Twice as much nitrogen means twice as much ammonia. What if, again, plenty of hydrogen, we're never going to run out. If we have 5 moles of nitrogen, how many moles of ammonia can we make? So 1 goes to 2, it doubles. 2 goes to 4, so 5 will go to 10. So if we have 5 moles of nitrogen, we can make 10 moles of ammonia. We can also use the other ingredient. This time we have an excess of nitrogen, more than we will ever need, and 12 moles of hydrogen. How much ammonia can we make? Well, we use our ratio. For every 3 moles of hydrogen, we get 2 moles of ammonia. So this one's a little more mathy. So our ratio is 3 hydrogen to 2 nitrogen. And that equals 12 over how many? We don't know. So I can just cross multiply, right? 3x equals 24. Divide by 3, and x is equal to 8. So if we have 12 moles of hydrogen, we can make 8 moles of ammonia. Just as simple with my ratio, becomes a simple math problem. Now, all this is with moles, right? These are moles. These are not grams. And as we have learned before, you cannot weigh out a mole of nitrogen. You cannot weigh out a mole of anything because we need a different balance for every element and every molecule in the universe. And so no one's going to have an infinite number of balances. So what we need is we need to be able to convert moles to grams. That is done via the periodic table, right? And that red number, or that number underneath on the periodic table, is the molar mass. So it tells me how to convert from grams to moles. Getting out my periodic table. So we've given ourselves some areas to do that, to convert all of these moles to grams. So 1 mole of nitrogen is 2 N's equals 2 times, we look up nitrogen on our periodic table. Its molar mass is 14.01. We can round that to 14. So 2 times 14 is 28 grams per mole. And we do the same thing with hydrogen. There's 2 hydrogens. We look up hydrogen on the periodic table. Its molar mass is 1.008. I'm happy to round that to 1. So we get 2 times 1, which is 2 grams per mole. And for ammonia, it's 1 nitrogen, so 1 times 14. And 3 hydrogens, which is 3 times 1. So that's 14, 3, we add them up, 17 grams per mole for ammonia. Okay, so these are my 3 numbers, 28 grams per mole for nitrogen, 2 grams per mole for hydrogen, and 17 for ammonia. So when we have these calculations to do with grams, we first have to convert. Right? So if I have 28.01 grams of nitrogen and 6.048 grams of hydrogen, how many grams of ammonia can be produced? Okay. Well, first thing I have to do is I have to convert both of those numbers to moles, which means I'm going to divide by these numbers. Okay. So 28 grams of nitrogen divided by 28 grams per mole gives me 1 mole. So I have 1 mole of nitrogen in 28 grams. 6 grams of hydrogen, 6 grams divided by 2 grams per mole gives me 3 moles of hydrogen. So I have 1 mole of nitrogen, 3 moles of hydrogen. So this is just this thing written out in grams. 1 mole of nitrogen, 3 moles of hydrogen. How many grams of ammonia can be produced? Well, I know I can produce 2 moles of ammonia, NH3. How many grams is that? So this time I'm going to multiply 2 moles times 17 grams is 34 grams of ammonia. So with this way, it's just like if you're weighing it out on a balance, right? 28 grams, which is 1 mole, 6 grams, which is 3 moles, makes 2 moles. 2 times 17 is 34. So I can make 34 grams of ammonia if this is how much product or how much reactant I have. Okay. Now, here's another one. If I have 28 grams of nitrogen and 25 grams of hydrogen, how much ammonia can be produced? Okay. So I have 28 grams of nitrogen. We just said that was 1 mole of nitrogen. 25 grams of hydrogen, we have to do this. 25 grams divided by my 2 grams per mole equals 12.5 moles of hydrogen. And it wants to know how much ammonia can be produced. Well, 1 mole of nitrogen, 12 moles of hydrogen. If I'm following my recipe, 1 mole, it doesn't matter how much of this I have. I only have 1 mole of nitrogen. So I'm going to run out, right? It is all I have. It is going to be used up. And I will have extra hydrogen. So again, if I have 28 grams of nitrogen, I can only make 34 grams of ammonia. Let me put a box around that. So that's all I can make, 34 grams, because I'm going to run out of this based on my recipe. Right? Now here, last one, 100 grams of nitrogen, excuse me, 12 grams of hydrogen. How much ammonia can I make? Well, 100 grams of nitrogen divided by 28 grams per mole is, I do have a calculator here, 100 divided by 28, 3.6. So I have 3.6 moles of nitrogen. Then my hydrogen, I have 12 grams divided by my 2 grams per mole. So I have 6 moles of hydrogen. So with my recipe, I have 3.6 moles of nitrogen, but I only have 6 moles of hydrogen. So my 6 moles of hydrogen are going to run out first as I'm putting these things together, right? But if I have 6 moles of hydrogen, I got to do my little ratio. 6 over X. What's my ratio for hydrogen and nitrogen? Hydrogen is 3 ammonia, is 2. So I have 6 moles of hydrogen. How many moles of ammonia can I make? Well, the ratio is 3 moles of hydrogen to 2 moles of ammonia. 3 hydrogen, 2 ammonia. Cross multiply, 12 equals 3x. X equals 4. So I can make 4, remember this is moles. I can make 4 moles of ammonia. How many grams is that? I go back up to here, my 17 grams per mole. So 4 times 17 is what, 68? Check on my calculator. Yes, 68 grams. So with my 4 moles of ammonia, that is equal to 68 grams of NH3. All comes from my recipe. That's where it all comes from. So there'll be some practice problems for you guys to do for this for your classwork today.